Hi guys, today we're going to talk about greatest common factor. A couple of vocabulary words that I want you to know is a factor is a number that multiplies with another number to get a bigger number. So 4 times 2 equals 8. So 4 and 2, the two numbers I multiply to get 8, are the factors. The greatest common factor is the biggest number that is a factor that is of 2 or more numbers. So we're going to do a few examples. There's a couple of common ways to get a greatest common factor. You will see right here. Probably the most common way, and the way you probably have done it the most in your past, has been to list all the factors. So if I am listing the factors of 12 and 42, I'm going to do 12. 12 is 1 times 12. It's 2 times 6, and it's 3 times 4. 42 is 1 times 42. 2 times 21. 3 times 14, and 6 times 7. When I look at those numbers, I look and I say, well, I start with the biggest one, so of the smaller numbers. So 12, I don't see a 12 down here. 6, yes, I do see a 6 down here. That means my greatest common factor would be a 6. Next, you can use the factor tree, which is probably one of the ways I encourage you to do it, because as a 6th grader going into 7th grade, you're going to be using factor trees in 7th grade. So if I have 12, that was my son. If I have the number 12, 12 is 6 times 2. And when I look at 6, I know I can multiply two other numbers to get 6. I can do 2 times 3. So 2 times 3. When I do 42, I know 6 times 7 is 42. And 6 is 3 times 2. Now, 3 is a prime number, 2 is a prime number, 7 is a prime number. So now I'm done with my factor tree. Now I have to circle the numbers they both have. They both have a 2. So I'm going to put 2 down here. I'm changing the way they did it down here just a little bit. And they both have a 3. A 3 and a 3. So now I have 2 times 3. What's 2 times 3? 2 times 3 is 6. What they did is they listed the factors. So 12, it is 2, 2, and 3. If you see that, 2, 2, and 3. That's what they put right here. 42 is 2, 3, and 7, and they did smallest to biggest. And then they circled what they both have. So they both have a 2. They both have a 3. And then you multiply 2 times 3, which would get you 6. So that's another way to do it. Let's do another way. This is a way that I've seen done, but it's not necessarily my favorite way. They use the distributive property. Using the distributive property, first thing you do is you write step 1, you have to find the greatest common factor. Or I guess this isn't really finding the greatest common factor, it's finding the sum of the numbers. So if I have, I feel like I just lost my train of thought because my dog is playing with his toy. I'm sorry. So I have 18 right here. Just a minute. Just a second. Sorry. I closed the whole PowerPoint. Sorry, I'm back. So what they did is, yeah, you have the greatest common factors here. So they did 18 is 9 times 2, and 9 is 3 times 3. 24 is 6 times 4, 6 is 3 times 2, and 4 is 2 times 2. So they listed them all up, and then they circled the ones that they both have, which is just like what I do. Well, they both have a 3, so I'm going to put 3. They both have a 2. I'm going to do 2. 3 times 2 equals 6. So now when you come down here, you've got 18 and 24. So now what they do is they take whatever the greatest common factor is. So 6 is my greatest common factor. And they're going to do, okay, 6 times what is 18? Well, 6 times 3 is 18. And so that's how they got 6 times 3. And then I have to add And then 6 times 4, what is 6 times, or 6 times what is 24? And that would be 4, so 6 times 4. So now I'm going to take my 6 out here, and I'm going to put inside my parentheses my plus 3 and my 3 and 4. So 3 plus 4 right here inside the parentheses. It's kind of a tricky little way to do it, but yeah. So let's come back to our lesson right here. We're going to find some greatest common factors. So we're going to start with 10 and 70. So when I look at 10 and 70, and in the lesson, I'm going to be using the prime factorization method. I feel like that is a very accurate way to get it. And as I said, as we're doing secondary math, I want you to do it in the secondary manner. And so I have 10 and 70. Well, 10 is 2 times 5. 2 is a prime number, and 5 is a prime number. 70 is 10 times 7, right? And 10 is 2 times 5. When I look at this, 7 is already a prime number. And so now I am going to circle the numbers that they both have. They both have 2 as a factor. So I'm going to put 2 right here. They both have 5 as a factor. I'm going to put that right here. 2 times 5 equals 10. So I am done with number 1. So the greatest common factor for 10 and 70 is the number 10. Let's do another one. Let's do 4 and 20. So I've got 4 and I've got 20. 4 is 2 times 2. And 20 is 4 times 5. 4 is 2 times 2. And now I have all prime factors. Now at this point, I have to find the ones that they have in common and multiply them. So I have 2 and 2. So I'm going to put 2. I have another 2 and 2. I'm going to put another 2. So now I have 2 times 2. 2 times 2 equals 4. So now I am done with number 2. Let's look at number 3, 18 and 24. 18 is 9 times 2. 9 is 3 times 3. Now I have prime factors for 18, and let's look at 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Now I have to find the ones that they have in common. So they both have 1, 3. So I'm going to put 3. They both have a 2. So I'm going to put a 2 right here. So I have 3 times 2. 2. I don't have any other 3s in both of the numbers, and I don't have another 2 in both of the numbers. So 3 times 2 equals 6. Now I am done with number 3. Let's look at number 4. 18 and 63. 18 is 2 times 9, and 9 is 3 times 3. 63 is 9 times 7. 9 is 3 times 3. Now I've got my prime numbers. The next step is circle the ones they both have. They both have a 3 right here. So I'm going to put 3. They both have another 3 right here. So I've got another 3. 3 times 3 equals 9. And so 9 would be my greatest common factor with this one. Let's look at number 5. 5 is a tricky one because I have 17 and I have 31. 17 is already a prime number. So it's 1 times 17. 31 is also a prime number, so it's 1 and 31. When I look at 1, 17, and 31, the only number they have in common is they have in common the number 1. So that would be my prime number. Let's do number 6, 14 and 28. Okay, 28 is 7 times 4, and 4 is 2 times 2. 14 is 7 times 2. Now I'm done. Now I've got to find the common factors. So I've got a 7 in both numbers. So I'm going to put my 7 here. I've got a 2 in both numbers. 2. 7 times 2 equals 14. So far, not too hard, right? Let's look at another problem right here. It says name 2 numbers that have the greatest common factor of 8. If I'm given a challenge like this right here, if I start with 8 and then I choose anything above 8, a multiple of 8 basically, then it's a greatest common factor of 8. And so if I do 8 and 24, because 24 is 8 times 3. Those are two numbers that have the greatest common factor of 8, because 8 is the biggest number that goes into it. Another example is I can do 16 and 24. 16, 8 times 2 is 16, and 8 times 3 is 24. So 8 is still the biggest factor that goes into both of them. Let's look at one more problem, and this one is like more of a real life scenario kind of thing. It says Al's garden is 18 feet long and 30 feet wide. He wants to put fence posts the same distance apart along the bolt length and width of the fence. What is the greatest distance apart he can put fence posts? So I'm going to draw it right here, right here, right here, right here. Here's 30 feet wide and 18 feet long. Well, I could draw it and figure it out, but let me do my greatest common factor. 30 is 3 times 10. 10 is 2 times 5, right? Let's look at 18. 18 is 9 times 2, and 9 is 3 times 3. When I'm looking at my common factors, I'm saying, okay, 3 is in both of them. So let me put 3 here. 2 is in both of them, 2 and 2. So 3 times 2 equals 6. So 6 is my greatest common factor, and because of that, 6 is how far apart the fence posts would have to be. So I would start right here. This is supposed to be 18. And I would go every 6 feet. So 6 feet, 12 feet, 18 feet, 24 feet, and 30 feet, and it's not drawn to scale. And then 6 feet, 12 feet, 18 feet. I would do the same down here. And I'm doing the same thing. So it is every 6 feet that they will put their fence posts. We're done with today's lesson. So have a great day.